Multiplication of binomials is complicated for some, especially when using special products. So instead of using special products, we will use the easier way, the Japanese multiplication. In Japanese multiplication, we will be using lines which will result to their intersection for us to get the desired product. Let's try this. For example, we will multiply x plus y to x plus y. We will be using different colors to indicate the variables. We will use blue to represent x and purple to represent y. So we will first draw a line here to represent x. So this line will represent x. And another line which will intersect the first line at a certain point, which is in here. So this will represent another x. So let's proceed to the y. We will draw a line parallel to the first line drawn. So this will be the y. And next, we will draw another line which will represent y that is parallel to the second line drawn. So this is the line which will represent y. And now, we will count the intersections made by the lines. It will be represented by a red color. So we will first indicate it from right to left. So this is the intersection of y and y. So y multiplied by y is y squared. So let's proceed to the second column. The intersection of x and the intersection of y, which is x multiplied by y, is xy. And aligned with this, the intersection of x and y is xy. So we have xy plus xy is equal to 2xy. And lastly, we will indicate the intersection of x and x, which is x multiplied by x, and it will result to x squared. Combining all the terms we got, we have in here y squared, which is positive, so we will indicate it as plus sign, and 2xy, which is also a positive, so we will indicate also it as in plus sign. And lastly, we have x squared. So the product of x plus y and x plus y is x squared plus 2xy plus y squared. Let's try another example, wherein we have two binomials of a variable and a constant. We have in here x plus 2 multiplied by the quantity x plus 3. So first, we will draw a line indicating x. So we have in here the first line, which is the representation of x. So we will write x in here. So again, we will draw another line intersecting the first line. So we will have it in here. So we have another line which will represent the x in the second binomial. So we will draw lines that will represent the constants. So we have two lines parallel to the first line drawn. So we have 1 and 2. So we have two lines parallel to the first line drawn. And another one, we will draw three lines parallel to the second line drawn. So we have 1, 2, and 3. In here, we will count the intersections made by the lines, so we will start from right to left. So we have 1, 2, 3, 4, 5, 6. So we will simply write 6 because it is the intersection of the constants. Next column, the intersection of x and the intersection of the constant is 2x, wherein there are two intersections made, which is 2 multiplied by x. So next is 1, 2, 3. The intersection of x and the intersection of the constant. So we have 3 multiplied by x, which is 3x. So combining 2x and 3x, we will have 5x. Lastly, the intersection of x and the intersection of another x, which is x multiplied by x, is x squared. Combining all the terms we got, we have 6, which is a positive number, so we will write plus sign. Next is 5x, which is also a positive sign, which is plus. And lastly, we have x squared. So the product of x plus 2 and x plus 3 is x squared plus 5x plus 6. Let's cite another example, wherein there is a negative constant in one of our binomials. We have in here x plus 2 multiplied by x minus 2. We will indicate the variables and the constants with different colors. We have blue for the x and green for the constants. So first, we will draw a line representing x. So we will draw one line in here, so it will represent x, and we will write x in here. And next one, we will draw another line intersecting the first line, which is also another x. So we have in here x. So let's proceed to the constants. We will draw two lines parallel to the first line drawn. So we have 1 and 2. So we will proceed to the next constant, which is 2. We will draw two lines. Since it's negative sign, we will represent the negative constant as broken lines. So we have one broken line, which is parallel to the second line drawn, or the second x, and another line which is broken also. So we have one broken line. So we will indicate, or we will mark the intersections made by the lines by the red color. We will start from right again to the left. So we have 1, 2, 3, 4. So we have 4 intersections. Since it's the intersection of a solid line and a broken line, it will be negative. So we will proceed to the next column. So we have in here 1, 2. It's the intersection of a solid line and a solid line, so it will become 2, a positive 2. And the intersection of a constant and x is 2x. So we have 2x in here. And another one, the intersection of it, it's 1, 2. So we have 2. Since it's the intersection of a solid and a broken line, we will have negative in here. And just add x. So we have in here 2x plus negative 2x. We have 0. Simply eliminating this term. So lastly, the intersection of x and the intersection of another x, we have 1 in here. So x multiplied by x is equal to x squared. Combining all the terms we have in here negative 4 or 4. Since it's negative, we will write it as negative. Since it's 0, we will not write it anymore. And lastly, we have x squared. So the product of x plus 2 and x minus 2 is x squared minus 4.